Hi and welcome back to another Tech Minds video. Now we've seen antennas like this in the past and the design of it is really nothing new, but I like the way this antenna comes in this neat little carry case which keeps it all together, and all for just a rough price of £100, so it was worth the punt. Now this antenna is a GP or ground plane antenna, so to help with performance and tuning you're provided with 4 ground radials. You also get this little loading coil, which is to only be used when operating on the 40 meter band. Generally, I've not had that great experience with 40 meter vertical antennas, so it'll be interesting to see how well this performs on 7 MHz. We'll then have this ground spike, which also includes the feeder connection in the form of an SO239 socket. The ground radials also push into this part using the banana plugs, and then the main extension element screws into the top. We then get this extension pole, which needs to be used for all bands, and then we have the main telescopic part. Now this telescopic part of the antenna also includes some printed lines for each of the bands that it covers. Now I'll show you that in a moment when we go outside to set the antenna up. Now the only 2 parts missing from this case is the feeder coax and of course a radio, but you can add your own of course. With the red extension part screwed into the ground spike part, I just pushed it into the ground like this. Of course, getting it perfectly vertical is a challenge in itself. Now if you're not wanting to operate in 40 meters, then you do not need to include that coil, so just screw the telescopic part into the extension part. However, my first test with this antenna will actually be on the 40 meter band at 7 MHz. And once we go back into the shack, I'll compare it with my end-fed wire antenna. And with the vertical parts assembled, it's now time to attach the included ground radials. On one end of the radials, there's a little banana plug which just pushes nicely into that red cylinder part. The ground radials are around 3.5 meter each in length, and for this test I simply pulled them out in a straight line directly from the connection point, and then just made sure that they're laid on the ground without any of them overlapping. Of course, if you wanted more radios or even longer radials, then you can add your own if needed. Now, as these are laid on the ground directly, they don't have to be resonant. The last cable to connect is the coax feeder, and this will be the cable which goes off to my transceiver or a radio receiver like an SDR for example. We then need to fully extend the telescopic part of the antenna, and as mentioned earlier, there are some guide points printed on the telescopic whip so that you can get in the ballpark area for that desired frequency that you want to operate on. Now once I have the telescopic element extended to where it needs to be, it's now time to check the SWR on my vector network analyzer. Now I did have to go back and forth a couple of times between the analyzer and the antenna just to shorten the length of it just by dropping it down around an inch at a time. Eventually I got to a point where I was happy with the SWR, and I managed to get an SWR of 1.3 right in the centre of the 40 meter band at 7.1 MHz. The band edges were also around 1.5, so it's nice to see we literally have the whole of the 40 meter band tuned and can use it without retuning, whether we're on the CW portion, the data portion, or even the phone SSB portion, which incidentally is where I'll do my testing. With my end-fed wire antenna connected to port A of an SDR Play RSPDX R2, and then this new vertical antenna connected to port C, let's just do some side-by-side comparisons. Now don't get me wrong here, I already know which antenna is going to perform better, but the vertical still proves to be useful on the 40 meter band, and this was during the day.
Well, when I was first licensed, I was completely homebrew. I still like homebrewing bits and pieces. The ATU I'm using is homebrew. I could use the internal one, but I'm not. I'm using this. It's got quite a big homebrew one here, and it works quite well. And I've got a 2 meter trans.
Im Moment habe ich da eine Röhren-PA dahinter, auch irgendwo bei 700 Watt in den Spitzen. Wollte ja auch nicht übertreiben. Und 10 Meter über Grund die Delta Loop. Ja, genau, gesprochen haben wir uns bestimmt schon.
Now later in the evening, I thought I would watch some paint dry while transmitting some FT8. Only joking, FT8 has its place in ham radio, even if it is just to test your antenna. Using the PSK Reporter website to see where my FT8 transmissions had been received on the 40 metre band, I was actually quite surprised to see some over on the east coast of North America. A good concentration of received signals are around Western Europe, but we do have an odd few spanning across Russia. Now the power output from my radio was set to between 10 and 15 watts, and I was using an ICOM 7100 transceiver. Now I just want to say a massive thank you to today's video sponsor, JLCPCB. Now if you're not sure who JLCPCB are, well, they're a one-stop electronics and mechanical manufacturing platform who provide exceptional quality services at a fraction of the price you'd pay elsewhere. Their services include manufacturing of PCBs from your designs to PCB assembly, 3D printing, CNC machining and mechatronic part manufacturing. Now part of amateur radio is experimenting, and sometimes we need to create our own circuits. Using electronic design software of your choice, you can create your Gerber files and upload them directly to the JLCPCB website with a click of a button. Simply choose your materials and board specifications and then place the order. Your new PCB prototype will be in your hand within just a few days. JLCPCB makes the whole process from design to manufacturing extremely simple, and you can get high quality PCB prototypes for just $2. In fact, if you sign up using my link, which is in the description of this video, you'll also get $80 worth of coupons that you can use on your order. Thanks again to JLCPCB for sponsoring this video. Now the following day it was raining cats and dogs, as it typically does here in the UK, so I didn't feel myself removing the 7 megs coil and then retuning the antenna for 20 meter band at 14 MHz. But after tuning using the printed 20 meter marking on that telescopic antenna, I managed an SWR of 1.3 smack in the middle of the 20 meter band at 14.2 MHz. I also checked the band edges and these were not more than 1.5. In fact, the top band edge dropped to around 1.1, so I could have lengthened the antenna slightly just to drop that resonant point at 14.2 MHz, but it's perfectly usable where it is. So I performed the same tests as before, but for some reason I'd moved the coax connectors around in the shack, so now the vertical antenna is on port B and the end-fed wire is on port C.
Nerves and stress by doing it from home. Anyway, enjoy your 4-day week. Sounds wonderful. Good timing. I'm going to take a break as well. I have to go upstairs and see the XYL. We have to discuss something. Paul, I don't know if you wanted to get on the air or not. You didn't mention that in your message. But I do need to take a break right now, and normally I would go down to 40 to see if there's anybody there I know. But if you would like to...
Before, like we tested on the 40 meter band, I thought it would be a good idea to test the antenna using FT8, so I made a few contacts for around 30 minutes or so. Then I checked the PSK Reporter website to be presented with this, and that's not bad for 10 to 15 watts I guess. Lots of signal reports from the east coast of the USA and even one down there in South America. Western Europe is packed with reports, and right across the globe towards Asia, specifically Japan, Thailand, and then heading further down south, we're seeing reports from Australia. Now this antenna is rated at 100 watts and can cover from the 40 meter band, which is 7 MHz, right up to the 6 meter band at 50 MHz, and the comparison with the end-fed wire antenna in this video was merely to show that this antenna works comparable to a home-based wire antenna installation. Also, you have to bear in mind that there are some technical properties of this antenna compared to the wire antenna. Now that's in terms of angle of radiation across the different bands. Now having a ground-mounted vertical antenna, say tuned for 6 meters, would only be any good for like those sporadic E moments. but not really good for that line of sight or local contacts because it's just far too low to the ground. In fact, you might find better performance on a tuned wire antenna for 6 meters. Another point to mention that always seems to crop up on videos like this is the cost, and it would be cheaper to build something yourself. Well, HF antennas are typically cheap and easy to make yourself, especially if you're just going to be making those wire antennas. Of course, a Yagi antenna for HF are typically huge in size, but something like this, nice and compact in an easy carry travel bag, has its place in the ham radio antenna market. Now, my personal experience with this antenna has been positive. The build quality seems pretty good, and I'm really liking those printed markers on the telescopic whip part, as this means that you most likely would not need to take an antenna analyzer with you on those portable days out, as most modern portable transceivers have built-in SWR meters, especially something like the X6200, which can provide a small band scan. Now, I'll leave a link in the video where you can grab one of these yourself, along with an extra discount. Until the next video, thanks for watching, and I'll see you guys in the next video.